Okay, today we're going to look at normal distribution, and this is a lesson that tends to be a little bit more difficult, so I'm going to take it a little slower, but I might go over the 10-minute mark. So a bell-shaped curve that is symmetric with respect to the mean of the distribution is a normal curve. The set of data that can be represented by a normal curve is called a normal distribution, and that's going to be an important thing to look for in these word problems. This is normal distribution. The percent of data below a data point is called a percentile. So you've seen on those tests before that you ranked in, say, the 85th percentile. What that means is you did better or as well as 85% of the people who took the exam. The picture you see right below here is going to be on your reference table. It looks just like this. And it will ask you questions. And it says a set of data is normally distributed. That's important. As soon as you see something like that, you would go straight to this part of your reference table. It tells you the mean is 50 and the standard deviation is 2. What you do is you draw yourself a curve. And it doesn't have to be perfect. In the middle, you put your mean. On your reference table, they show it as 0, but in this case, your mean is 50. The standard deviation is 2. I need you to draw 3 lines in each direction. The standard deviation tells you what you go up and down by. So we're going up and down by 2. So 52, 54, and 56, 48, 46, and 44. I want to find the percent of data values that are less than 50. So I want to find all the percent below the 50 or below the 0 on my reference table. What I do is I add up all of these percentages. So you say 0.1 plus 0.5 plus 1.7 plus 4.4 plus 9.2 plus 15 plus 19.1. When you add them all up, it's 50%. What percent of the data values are between 48 and 52? Well, that means you're looking for that percent right there. Now, these lines that I drew, remember I told you the 50 corresponds to the 0 on the reference table? The other numbers correspond to the 1, 2, and 3, and the -1, -2, and -3, not the halves. We don't usually draw the halves. So what I'm really looking for is the percent between the -1 and the 1 on my reference table, which is 15, 19.1s, and the 15. So we add those up. And you add those up, you get 68.2% lie between 48 and 52. Find a data value that's 2.3 standard deviations above the mean. Well, the mean is 50. Above means add. 2.3 standard deviations. Each standard deviation is worth 2, so 2.3 times 2 equals 54.6. So at 54.6 is 2.3 standard deviations above the mean. And finally, you want to find the percentile of 46. That means you want to find the percent below 46, which on my curve would represent the black piece there. Remember, 46 corresponds to the -2, so you'll add the 0.1, 0.5, and the 1.7 to give you 2.3 percentile. Let's try another example. For a normal distribution, what percent of data values are between 1 standard deviation below and 1 standard deviation above the mean? So it actually doesn't give us mean and standard deviation values, so we'll just use the ones that they have on our reference sheet. At first, I want to find the between 1 standard deviation below and 1 standard deviation above the mean, so that's the red area. For that red area, if I add them up, we did do it earlier, it's the 15s and the 19.1, and it ends up being 68.2%. below 1 standard deviation below the mean, well, 1 standard deviation below the mean is the -1. Below that is my blue area. So you add up all the percentages in your blue area, which are 0.1, 0.5, 1.7, 4.4, and 19.2, and that gives you 15.9%. And they don't show a space here, but this one is a part of it. Below the mean, 50% of the data is below the mean, 50% is above. Let's try a couple word problems. The Play in Life and MP3 player is normally distributed. A mean of 30,000, standard deviation is 500. So let's draw our curve. The mean is 30,000. Standard deviation is 500, so 30,500, 31,000, and then 31,500. And in the negative direction, 29,500, 29, and 28,500. I want to say, it says, Matt's MP3 player lasted 31,500 hours. His MP3 player lasted longer than what percent of the other Euclid MP3 players? So I'm looking for 31,500. And I see that it is right here, which on my reference sheet corresponds to the 3. And it says it lasted longer than what percent? Well, it lasted longer than all the people below him. So what you could do is you could add up all of the percents below the 3, or just take 100% and subtract the other side. 100 minus the other side is 0.1%, so that will be 99.9%. Choice 4. Let's look at the heights. The heights of a 10-year-old child are normally distributed a mean of 138, standard deviation of 5. So let's draw our curve. 138 goes in the middle, and you're going up and down by 5s. So 138 plus the 5 is 143, plus 5 more, 148, and then 153. In the negative direction, 133, 128, and 123. It says the height of the 10-year-old child who is as tall or taller than 95.6% of the children. That's a percentile. What that means is we need to add up the percents until we get close to 95.6%. I know below the mean I've got 50%. So for 138 I'm up to 50%. Now I'm going to add the piece for the +1 of the standard deviation, which is 19.1 and 15. So 50 plus 19.1 plus the 15 is 84.1, so I'm not there yet. Now to get to the 2, I would have to add 9.2 and then 4.4. So 84.1 plus 9.2 is 93.3 plus, I forgot the other number already, 4.4 is 97.7. So when I took 84.1 and added 9.2, I got 93.3. And then I added the other 4.4 to give me 97.7. 93 is too low, 97 is too high. So I know I'm somewhere between 143 and 148. So I can cross off choice A, choice D, and that's it. Remember, the halfway mark, the 9.2, was too low. Let's find the halfway between 143 and 148. Just take the average, add them up, divide by 2, it's 145.5. So when I added the first piece, I got up to 93.3. That was too low still, so 145.5 is too low. It's not choice B. It's got to be choice C. So when you're in between two values, you do need to show me that in-between point. And I'll do the coffee one, you guys do the library one. So it says the coffee is packed in 16-ounce cans. The mean weight is 16.1, standard deviation is 0.04. What percent of cans can be expected to contain less than 16 ounces of coffee? And then what percent of cans can be expected between 16 and 16.2? You know what? I'm actually going to have you guys try both of these last ones to see how you do. Please take your time on them and see what you understand and what you don't understand.